All right, welcome back. Negative exponents part two. So here where you have much more complex things that we're dealing with. And if you look at this first example, it's much more complex because we have a negative exponent inside the parentheses, we have a positive exponent inside the parentheses, and then we have a negative exponent on the outside of the parentheses. So we've got a bunch of different things that we need to deal with here. And there are a couple of different ways we could approach this. We could first look at what's inside the parentheses and deal with the negative exponent there. And if we do it that way, what we're going to end up with is z to the sixth over y to the third, and then that whole thing is to the negative sixth power. Okay, we could apply that method. We could also just apply the power rule and multiply the exponents on the inside by the exponent on the outside. Okay, so you can do it either way. I'll show you this method first that I started here, since we have it started. So we have z to the sixth over y to the third, and it's all to the negative sixth power. If we apply the exponent rule now, or sorry, if we apply the power rule now, and you know what, actually there's a third way we could do this, but if you see it, that's great. So we're going to apply the power rule, and the power rule says I multiply the negative 6 times both of the exponents on the inside, so I end up with z to the negative 36 over y to the negative 18th. Okay, and now since they're both negative, that means they're going to switch places and become positive, right? So we have y to the 18th now in the numerator, and z to the 36th in the denominator. Okay, so we're getting some crazy big exponents, but that's okay. We can just treat them as regular exponents. They're just regular numbers. They just happen to be bigger than what we're used to dealing with. Okay, so now if I were to do the power rule first, I have y to the negative third, z to the sixth, and that whole thing is to the negative sixth power. If I apply the power rule first, I end up with y to the 18th and z to the negative 36. Okay, and then the only thing that I need to move is that z to the negative 36. So the y to the 18th, that's a positive exponent, so that stays in the numerator. So I have y to the 18th over z to the 36th. Okay, so you can see I got the same answer. All right. Was there one other one? There was, and what was I thinking? Oh, I know what I was thinking. If we take this, the first one that I did, where we have z to the sixth over y to the third, and we take it to the negative sixth power. Another way we could treat this is we could apply the negative exponent rule with the negative 6, and we could just flip this fraction over. So we could say we have y to the third over z to the sixth, and then I just change that to positive. And then I apply the power rule. So I have y to the 18th over z to the 36. And so you can see I ended up with the same answer with all three of those. So it's just three different ways we can approach doing this based on the different rules that we have. And really it depends on what you see and what you prefer. So it's up to you. There isn't necessarily one right way to do it. All right, if we look at this next one throws a whole bunch of stuff at us. And there's a whole bunch of different ways we could do this, but what I would do is I would eliminate the parentheses up on top. So in order to eliminate the parentheses, I have to apply the power rule. So I'm going to apply the power rule here, and I'm going to end up with 2 to the 4th power, and then x to the 12th, because 4 times 3 is 12. And then I have this extra x, and I'm just going to say times x, all over x to the 7th. Okay, so now I just have a bunch of simplifying to do. So I'm going to simplify this. So 2 to the 4th power, 2 times 2 is 4, times 2 is 8, times 2 is 16. So that becomes 16. And then x to the 12th times x to the 1 becomes x to the 13th. And then it's all over x to the 7th. But then now we can apply the quotient rule here, because we're dividing with exponents that have the same base. The x is the same base, so we can subtract the 7 from the 13, so we end up with 16x to the 6th power. Okay. All right, and there's a bunch of different ways you could do that. You don't have to do it this way that I did it, but whatever you see, and if you end up with the same answer, that's perfectly fine. All right, so with this one, my preferred method for doing this one, and I've talked about this already a little bit, is I'm going to apply the negative exponent rule first. So the negative means I need to flip these two things and just change that to positive. So I'm going to end up with b over 3a squared to the 3rd power. So the fraction just flips over, and I change the positive to positive power instead of a negative power. And now I can apply the power rule. So the power rule says I multiply every exponent. Remember, there's a 1 there. There's a 1 on the 3. That's easy to forget. So we have b to the 3rd power, 3 to the 3rd power, a to the 6th power, because 3 times 2 is 6. And then the only other thing I could do here is simplify that 3 to the 3rd power. So I have b to the 3rd over 27a to the 6th. All right. 1 or 2 more? 2 more. We can do it. Oh, man. Lots of negatives. Okay, so in this case, what we have to do is just simply identify what's moving and what's not moving. So this is going to move, this is going to move, this is going to move, and this is going to move. And you'll notice I highlighted everything that has a negative exponent on it. And if it has a positive exponent, it's staying. So we're going to end up with having y and x squared stay, right? And then everything else is going to move. Okay, so we have 4 to the 3rd, because the 4 to the negative 3rd moves to the numerator. We have 4 to the 1 power, but I'm not even going to write well, I probably should, just to keep it from getting confusing. So I changed the sign from -1 to +1. Okay, and then the x to the negative 3rd is going to come down to the bottom, become x to the 3rd. And the y to the -6 comes up to the numerator, becomes y to the 6th. Okay, so my preferred method is just to move everything first, get rid of the negative exponents, and now we have to do some multiplication or the product rule, and then we're going to have to do some quotient rule. Okay, so if we do the product rule first, we have y to the 1 times y to the 6th, and then we have 4 to the 3rd power. And you'll notice I'm going to leave that 4 to the 3rd power as 4 to the 3rd power, and you'll see why in a second. So this becomes 4 to the 3rd power, y to the 7th. And then we have 4 to the 1st power, x to the 5th, because we're adding those exponents. Okay, and this now is why I didn't simplify the 4 to the 3rd, because now I have to apply the quotient rule to that. So 4 to the 3rd over 4 to the 1 power, I'm going to subtract that 1 from the 3, so I end up with 4 squared. And then I have y to the 7th and x to the 5th. And then one more thing we can do with this one is just simplify that 4 squared, make it 16. And so we end up with 16y to the 7th over x to the 5th. All right, so in this case, this was a great example of some things had positive exponents, some things had negative exponents. We didn't have to move everything. We only had to move some things. Okay, and similarly down here in this last one, we have the same thing going on. So we've got a -2 there. Wait a minute. No, I just made the same mistake that you guys might make. No, that one's not going anywhere. That's staying where it is. The only thing that's going to move here is that -1, that y to the -1. So it's going to move to the numerator. Everything else is going to stay where it's at. So we have -2x to the 3rd y, and then we have times y to the 1, because that y to the -1 becomes positive. Okay, we're going to have an x on the bottom, or in the denominator. Okay, so now we just have some simplifying to do. So we have -2x to the 3rd, and this is going to become y squared, because y1 times y1 is y squared, all over x to the third power. And now we have a couple of choices from here how we want to proceed. We could apply the quotient rule first, and we could eliminate the x in the denominator. And I almost kind of prefer to do that because it just is going to kind of make the power rule a little bit simpler. So we have -2, and then x to the third, and this is x to the 1, so it's going to become x squared, y squared, all to the third power. Okay, and then now we can apply the product rule, which says we have -2. So this is going to get a little, so the parentheses are going away at this point, but I'm going to add parentheses because I'm doing -2 to the third power. And then we have x to the 6th, y to the 6th. Because of the product rule, it says to multiply the exponents. And then last thing we need to do is just do -2 to the third power. Well, any negative number to an odd power means it's going to be negative, and it's going to be -8. X to the 6th, y to the 6th. All right, so these are a lot more complex. And the key is just identifying what stays, what goes, and you should be okay.